2.4, use partial quotients. I can use partial quotients to divide a multi-digit number by a two-digit divisor. Spark your learning. Team Med Butters is participating in an obstacle course marathon. For each obstacle, the team completes $90 is added to their prize bank. The team completes 12 obstacles. If each member takes home $66, how many team members are on the team? So what's our information we need? Well, it's going to be a two-step problem, right, guys? Okay, so first of all, we're going to have what? The $99, 12 obstacles, and each one takes home $66. Okay, so what do I need to do? 99 times 12. 2 times 9 is, carry the 1. 2 times 9 is 18 plus 1 is 19. Mark off the 1, mark off the 2, put a 0 to hold our spot. 1 times 9 is, 1 times 9 is, then add them. So 8, 18, carry the 1, 11. So 1,188, correct? Okay, now we've been finding partial products and we've been using a box, right? Okay, what's another way that we can do it? Can we go ahead and set it up in the house? Yeah, okay, so we could go ahead and set it up like this and divide by what? 66, okay? Now, what would be an easy thing to start with? It's 10, right? So we could take 66 times 10. What is 66 times 10? 660. So we subtract that out. 8, 2, this becomes an 11 and this becomes a 0. What's 11 minus 6? 528. Okay, now can we do times 10 again? No. Okay, can we do times 2? Yeah, what would that be? What's 66 times 2? Oh, hold on. Okay, so 6, 12, this becomes a 4, right? So 9, 3. Okay, can I do that again? Yep, 66 times 2, and we said that was what? 132. So 4, 6, 2. Can I do that again? Okay, so minus 132. So 2, 3, 1. So I can do it one more time, right? Okay, now what do I need to do? I'm going to put a box around these and add them all up. So 2 or 10 plus 2 is, plus 2 is, plus 2 is, plus 2 is. So there's how many team members? 18. So let's see number 1. Another team adds $594 to their prize bank. If each member takes home $54, how many members are on the team? What equation can you write to model the number of team members that complete the obstacle course? So what do we need? A circle. $54. And how many team members are on the team? So what am I going to do? Equals the number of members, right? About how many team members complete the obstacle course. So we need to, we always say we estimate because of about, right? And we always estimate what first? The divisor, right? So 54 we'd estimate to what? 50, okay? Or we could do 55, right? Okay. But what would be better? What can we do the 594 to? Can we do 600? Because you can take 50 into there, right? So that equals, get rid of a 0, get rid of a 0, How many times does 5 go into 60? 12 times, right? Okay, so our answer should be close to 12, right? So find the number of members that complete the obstacle by dividing these partial quotients. What number is the divisor and what number is the dividend? So the divisor is what? Is 54. The dividend is 594. Okay, and then sometimes it is easier to divide greater numbers than use small steps. Dividing with partial quotients means subtracting multiples of the divisor from the dividend until the remaining number is less than the divisor. We just did that on the other side, right? Okay, so the partial quotients are then added together to find the whole number. Use your estimate. What multiple of the divisor can be subtracted from the dividend? What did we say works best? Units of 10. Okay. And then subtract this multiple from the dividend. Okay, so we're going to do it and keep going over and over, right? So we have 594 divided by 54. What can I do, guys? Times 10. So 54 times 10 gives us 540, right? And then 454. Now what can I do? And do you see how I put it right by those things, guys? Does that help me keep everything organized? Yes. So equals 54. Nothing left over. So I'm going to put that in there. 10 plus 1 is 11. Okay. And we went ahead and subtracted out. Do we have a remainder? Nope. It's 0, right? So how many members? 11 members. And how do we know that our answer is reasonable?
Because our estimate was 12 and that's 1 out.
Okay, so our estimate is close to our actual answer. 11 and 12 are really close, right? Okay. Step it out. Number 2, a countrywide field day registers 1,468 participants. Each participant receives a ribbon. The ribbons are bundled in packages of 25. How many packages of ribbons are needed? So we need the 1,468 participants. Packages of 25. How many packages are needed? Write a division equation to model the number of packages. So what are we going to do? Okay, equals the number of packages, right? And then an estimate, we always start with the divisor, right? Would be 25. What can we do for 1,468? We can do 1,500 because we know how to use quarters, right? So how many quarters would be in $1.50? 6, right? And then just adding, so about 60, right? Okay, so we're going to go ahead and do our problem. So 1468 divided by 25. What can I do? 25 times what?
10.
Okay, times 10. Could I even do times 40? Could I do times 40? Yeah, because how much is 4 quarters? $1. So 425 is 100, right? And then add a 0. So that would be what? Now, if you don't feel comfortable going that high, that's perfectly fine. The only thing is if you don't go that high, you're just going to have more subtraction, right? Or a few more steps, which is perfectly fine. It's whatever you feel comfortable with. So 468. Now I can do 25 times, how many 25s go in $4? 16. We can stick with 4 though, right? And get 100, right? So then that would be 368. Do 25 times 4 again and get 100. 268. 25 times 4 again and get 100. 168, right? Okay, 25 times 4 and get 100 and get 68. Okay, now I can do 25 times what, guys? Times 2 and get 50. And I have 18 left over. Okay, so let's look what our whole number is. So we need to do this. So 40 plus 4 is, plus 4 is, plus 4 is, plus 4 is, plus 2 is 58, right? Okay, so our answer is 58, remainder 18. So how many packages of ribbons are needed? They need 59, right? Because you can't just leave those 18 participants out, right? Right. So 59 packages. Check understanding number 1. There are 439 flower seeds in a packet. The gardener puts 36 seeds in each seed starter tray. How many trays can the gardener fully fill with one packet of seeds? So we have 439 flower seeds in the packet, 36 seeds. How many trays can they fully fill with one packet? So we need to pay attention to what they want, right, guys? So what am I going to do?
I'm going to do 439 divided by
10. Okay, so what can I do first?
times 10.
Okay, 36 times 10. And that gets me what?
36.
And then that is 9. This becomes a 13. This becomes a 3. So 7. Now what?
We can take 36 times
2, which is 72. And we have 7 left over, right? So our answer is 12, remainder 7. So how many trays are completely full? 12, right? Because in this case, we have 7 left over, but they want to know how many trays are completely full. So all we're looking at is the quotient, right? So 12 full trays. All right, so this is number 1. Number 2, we're going to do 728 divided by 28. What am I going to do first, guys? Let's do 28 times 10. What's 28 times 2? 56. So would that get us a little closer? Okay, so times 20. If you guys want to do 10 and you feel more comfortable with it, that's perfectly fine too. Like I said, you're just going to have a few more steps, right? So 560. So this becomes a 12 and this becomes a 6. So 8, 6, 1. Can we do 28 times 10 now? No, but you just told me that 28 times 2 is 56. So that leaves us with 12, 112, right? So I could do what? Because we know 28 times 2 is 56. 56 times 2 is 112. So we could do it times 4. So are there multiple ways to go about what you use over as your partial product? Yes, it's just whatever numbers you feel comfortable using. So then we have nothing left over. So 20 plus 2 plus 4 is? So our answer is